Okay, hello everyone, welcome back to Code Enzyme, and in this video I will be solving Biweekly contest 127. So, like last time I did it, just like last time where I created a virtual contest. In this video, I'm thinking, there is no need to create a virtual contest, I will just solve these problems one by one. And if there is some problem that I'm not able to solve, then maybe I will open the solution tab and see. Okay, so let's read the first problem. This is 3095, shortest subarray with or at least ki. Okay, you are given an array of non-negative integers and an integer k. An array is called special if it's the bitwise or of all the elements is at least k. Okay, return the shortest special non-empty subarray of nums or return -1 if no special. Okay, so we have nums dot length less than equals to 50 and nums I less than equals to num size also very small. So I think I can just, this is the constraints are, since the constraints are very low, what we can do is we can simply create a subarray like thing, just create a nice subarray and we are good to go, right? So what I'm going to do is, I'll be using Sublime to code, okay? So if you want, you can criticize me for it, I don't really care. But yeah, I like Sublime Text since the Leetcode does not have those features like debugging and all. So I like to code it on Sublime. Okay. So let's say 1, 2, 3 and int k equals to what? K equals to 3, right? And let's say solution s and see out s dot minimum subarray length of nums and k. Okay. Wait a second, let me just read the. Okay, so we have two of them, like shortest subarray with or at least one and shortest subarray with or at least. Okay, so let's read the second part also. I think I will try to solve both of them simultaneously. Okay, so if you are given an array nums of non-negative integers, so these are basically the exact same problems. But this has constraints of length 2 into 10 to the power 5. Okay, so what I can do is I can directly try to solve this problem first and then I will go to this problem and then I will submit the same code here also. So there is no really need to solve this one, right? And this problem is quite easy, first one. So I think I will just move to the third problem right away. Okay. So 1 and 2 are given in the same contest. So okay, so first we want to find a subarray. So let's say we have a1, a2, a3 till an, and we want to find the shortest length subarray uh, whose or, so bitwise or of, let's say this is I and this is j. So bitwise or of ai plus 1 till aj is greater than equals to k at least, right? And we want to find the minimum length of this subarray. And the constraints are, let me just write the constraints. So the constraints are n is still 2 into 10 to the power, what happened? So 2 into 10 to the power 5. What else? Num psi is going from 0 to 10 to the power 9. So these are in 32-bit integers. So we can contain it in normal int. We don't need long for this. What else? Yeah. Okay, so clearly I think this is a sliding window problem. And so I can keep going right till the answer is at least k. And once I reach here, like from 0 position, I will reach some j value. uh, I will keep ORing the values, and once I reach here, when the or is greater than equals to k, I will try to move the left pointer as forward as possible, and this I have to keep doing it till my answer is that. This is one approach, and this will work in big O of n log n. What else can I think of? Like if my answer is k, my answer can also be k plus 1, right? And if the answer is k plus 1, my answer can also be k plus 2, and so on till n. So if my so the this is the k will be the minimum value possible. So maybe I can also do a binary search. So what I can do is if I have I mean the low is equals to 1 and high is equals to n, right? So the answer I can try to minimize the answer. So if I will get the window length, so window is equals to mid. So this mid value will represent the window length, and then I can try to binary search on this answer like that. So that will also work. So you can this will, but this will be n log of log square n. So I don't think it is necessary, but yeah, I think we can also try this also. Yeah. But I think this will suffice, and this might be the first approach that comes to mind. So let's see how you can implement this one. Okay. Okay. So to implement this, since we have 32-bit integers, and so what I will do first, let's get the length of this nums array. So nums dot size, and we will have a count vector of n 32. Initially, all the values will be 0, and let's also have the len value. So length is initially 0, no elements are in this window, so this will represent my window. Okay, and now I want to have three functions to add an element in this, remove an element in this, and get the value of this window. Okay, so for that I can do, let's say, auto. I will have functions. So first is the add function. This will take a parameter x, and this will add this x value to this window. So this is a void function clearly. So what I can do is for I in range 32, I think it will allow till 32. Otherwise, I will have to make long. Uh, what will I do? Answer count of no. If x and 1 less than I, left shift 1 by I indices. If this is, then I will say count of I plus plus. Okay. Similarly, also after this, I will have to say len plus plus. So I'm increasing the length of this window. Similarly, I will have a function for remove to remove this x value. So count of I minus minus and len minus minus. Okay, and there will be one more function to get the value of this window. So this will be value get function, and this won't take any parameters. So if let's have answer variable, and I can do something like if count of I answer is equals to answer or 1 less than I, and in the end we can return the answer value. So this is my window, count value, add value, remove, and get. And now I can simply do how should I say this, like, let's say my final answer is equals to n plus 1 because that is the upper limit. And now let's say left pointer is equals to 0, and we will add this uh, nums of L to the to that window. If get is greater than equals to k, then I will say answer equals to 1. Otherwise, I will run a for loop r equals to 1, r less than n, and r plus plus. Okay. And now I will try to add this new value to the window. So I will say add nums of r, and then while get is greater than equals to k, I will try to decrement the answer. I mean, like, I can say answer is equals to min answer comma len, and uh, remove remove of what, nums of L plus plus. So remove the L value and then increment the nums pointer, and if still my get value is greater than equals to k, then answer is equals to min answer comma len, and in the end if my answer is still equals to, because I think we had to print a -1, so if the answer is still equals to n plus 1, I will simply return -1, otherwise I can return an answer value. So let's run this. Okay, we are getting a 1, and so the output here also is 1, so let's try to submit this one. Okay, so okay, we are getting some kind of errors. Why is that? Last executed input, what is the error? Address, okay, let's try it for this test case, 1 2 and k equals to 0. Okay, we are getting some very large value, and why is that? Now let's try to debug this. So if I debug nums 1 2, which is okay, so we added 1. Hmm. Now the answer is 0. Okay, I think because k is 0, I think I can handle it separately if k is 0. Uh, so what I can do, if k equals 0, simply return 1. So yeah, I think that should work now. So just a line I added, if k equals 0, then I will return 1. Okay, so our solution got accepted, and now, I mean, should I look at other solutions also? Let's say if there was a better way to do it. Yeah, there was a binary search way, and I think they're talking about the same thing only. Let's let's just submit the same thing for here also. And then we have to go to the next question, minimum levels to gain more points. Okay. Okay, let's read the problem statement. You are given a binary array possible of length n. Someone, I don't like the name. Let's just call him a person. Person and Bob are playing a game that consists of n levels. And if some of the possible levels of the game are impossible to clear, while the others can always be cleared. Okay. So if possible I equals 0, then the ith level is impossible to clear for both players. A player gains I points on clearing the level and loses I points if the player fails to clear it. Loses 1 point. Okay, so loses 1 point. So whenever possible I equals 0, basically uh, that player will lose it. Okay, so at the start of the game, the person will play some levels in given order. So what does the given order mean? And the other player will play the rest of the. So can he play, like, can he skip some games? So in here the output is 1y. I mean, he can play 2 games like this. So The answer should be 2. So okay, so he says like okay, he will play only this game, and the other player will have to play all the other three games. So I mean he can only play the third game also, right? No, he can't play the third game. So in this word in the given order means that he will have to play some kind of prefix and the other player will play the some kind of suffix like that. Okay, so let's have this test case. Um, Class solution vector int possible, and this is 1010. Yeah. So if we have this, first thing that I can do is I can convert all the zeros to -1. So for int and I in possible, if I equals 0, I equals to -1. So all the zeros will be converted to -1s. And let's get the length of this. Now, okay, let's say we have a stream of zeros and ones. Sorry. So if we have something like this, now in this case the player will not be able to win. So let's just leave this. So 1 -1 1 -1. So at any point, I mean, what are the constraints? The constraints are like 10 to the power 5. So we want to do this in big O of n time or big O of n log n time, something like that. Okay. So at any point of time, I need to find the sum of this. Like if I am at some index I want to find the sum of 0 to I and sum of I plus 1 to the end of this array. So for this we can use the prefix sum, and for here to get this we can use the suffix sums, right? Okay, so it is pretty straightforward. We want to find the minimum index I such that the prefix sum is greater than the suffix sum, and then we will print that many games that he has to play. So let's say vector int prefix of n and suffix of n. Why are these blue? Maybe because, yeah, let's just name them prefix and suffix. And obviously prefix of 0 will be equals to what? Prefix of 0 will be equals to possible of 0, and for I in range 1 to n, prefix of I equals to possible of I, and prefix of I plus equals to prefix of I minus 1. So this is the prefix array, and for the suffix array this will become n minus 1 and n minus 1. We'll go in reverse order. So let's say n minus 2, I greater than equals to 0, and I minus minus. This will become suffix. Okay. Suffix of I equals to possible I, and suffix of I, suffix of I plus equals to suffix of I plus 1. So that will make the suffix array. Now what can we do? Let me read the statement again. Wait, is the recording working? Yeah, it is working. Okay. Now, at the start of the game, minimum number of player. Note that each player has to play at least one game. Okay, so we can't go till the end index. So let's say we are going from I equals to 0 to I less than n minus 1 because we can't go till end index, right? So, and someone, or I can say the player 1 will play prefix will get prefix I points, and in P2 he will get the suffix of I plus 1 points, and if P1 is greater than P2, then what? I will return I plus 1 because they have to play like I plus 1 games, like one game. So basically 0 means 1 in this case. And if still the loop and if after the loop is over, then if still we are in this function, then I will simply return a -1. Okay, this looks correct. Let's try to just run the test first. Okay, I think I made some mistake. uh, okay, let's try this one. 1111. It says 3 games, which is correct. For 00, I mean, for me it is working right now, but I don't know why it is not working there. Why is that? Is it because of this function? Let me just change that a bit and run this. Heap buffer overflow on the address at this pointer. I'm not really sure why this is happening. Okay, let's see. Why will this happen? Maybe if I make this n+1 and n+1 possible 0, yeah, possible n-1, and okay, let's try making this n+1 and n+1. Maybe then it will work. I'm not sure why this is happening. I think I will just code the same thing in Python. So what do we have here? And if I want to do the same thing or should I just convert this code using ChatGPT? I'm not really sure. Let's just do this in Python. Sorry for the inconvenience. Now, okay. So if we have this, then first thing that I want to do is len possible. Yeah. Then what? We want to have, first of all, for I in range this, if possible I equals to 0, then possible I equals to -1. Okay. Then I want to have the prefix and suffix array. So let's say prefix is equals to possible 0, and let's add it in the make a list of it. For in range 1 to n, prefix dot append what? Prefix of -1 plus possible n. Okay, so that will make the prefix array. And similarly, I want to have the suffix array, but this time let's say n-1, and this will go in reversed range from 0 to n-1. So this will become suffix and suffix dot append. So it is like that, suffix of -1, and then I want to say suffix dot reverse. Does this work? Let me just try and run this. Yeah. Let's say s is equals to solution. and I want to print the s dot minimum levels. Okay, two positional arguments. Oh, sorry about that. Okay, so I'm getting none, which is good. Print prefix, print suffix. Yeah. So in prefix we have 1, 2, 3, 4, 5. We have 5, 4, 3. So this is good. Okay. Now, now what I want to have, like for I range this for I range n minus 1. I said p1 is equals to prefix of I, p2 is equals to suffix of I plus 1. If p1 is greater than p2, then I return I plus 1. Otherwise, I will return a minus 1. So yeah, now it works. Let's try to submit this. Let's first run the test. Okay, now it is passing, and when I submit it, yeah, solution got accepted, but okay, we are beating only 50% of the solutions. That's why then. Should I see the other solutions also? I'm not sure. Let's just go back and try the next problem. So we have solved three of them, and now this is the sum of sequence powers. Okay, let's switch to C++ only. Is the recording working? Let me just check. Yeah. Now find the sum of sequence powers. You are given an integer array nums of length n, and we want to find a positive integer k. A power of subsequence is indeed the minimum absolute difference between any two elements in the subsequence. The sum of power of all, so power is basically defined as the minimum absolute differences between any two of the elements. Okay. And we want to find the sum of power of all subsequences of nums which have length exactly equals to k. And we want to print it modulo 10 to the power 7, 9 plus 7. Okay. So basically with length 3 we have these four subsequences, and 1, 2 will be the minimum. Okay, 2, 3. Then 3, 4 we can say, yeah. Then 2, 3 again, or maybe 3, 4, but both of them works. So the sum is 4, like that. Okay. So this is, I mean, whenever you have a counting problem, I generally think about dynamic programming. So if you have a counting problem, it is, in general, it is a dynamic programming problem. So, okay, I will just tell you, like, there are three kinds of problem that I think a DP can be involved. One is the counting. Okay, so whenever you have some counting problem, whenever you have some optimization, that is minimization slash maximization, then I get a feeling that this is a DP problem. Should I check the tags? Okay, there are no tags available. Okay. Ah, okay, but what are the constraints? So constraints are n is going till 50. So n is 50. So it is, which is equals to 100 upon 2. And since we have 100, then 100 to the power 4 will work. So we can go till big O of n to the power 4, something like that. The nums I, so AI is going from 10 to the power 9, 10 to the power 8 actually. Is it 8 or 9? Yeah, it is 8. What else? 2 from k to n. Okay. Sorry about that. No. Okay, whenever we want to solve such kind of problems, um, what I think about is like one way is to one way is like knapsack DB. So is it something like knapsack DB? So basically, is it like I mean, we want to have subsequences, right? And subsequence means we can delete some of the elements. So, and the minimum differences is like we can have a big O of n square differences at max. But that is a tedious task. Like whenever I take or not take, it will really depend on what the previous element was. Like if I have some array a1, a2, a3, a4 till an, okay. So if I take this array in the subsequence, then I let's say I skip this and a2, and if I take a3 and then let's say I skip a and then I take a4. Uh, so if I do such an approach, I have no way of knowing if the difference between a1 and a3 was less, or a1 and a4 was less, or a3 and a4 was less. So this checking part will take me big O of n square time. So this will increase my time from big O of n to the power 4 to big O of n to the power 6, and this will give me a TLE. So that won't work. Okay, what else can we do? Okay, maybe okay. Let's try it. I mean, we have only n square differences, so maybe we can count how like every difference, how much does it contribute to the answer, something like that, using contribution technique. Okay, I think I get it now. When we have what we can do is we can just sort the array, and once the array is sorted, let's say without loss, I mean, why can we sort it first of all? Since it is a subsequence, the elements don't really matter, and since we are taking the absolute differences, if this absolute sign was missing, I will not have tried to actually sort them. So let's say we have a1, a2, a3, a4. So if this is like this, then I know the differences can only be the consecutive elements in the subsequence, right? So now it will not take O of n square time. It will reduce to big O of n times, and and like that. So it will actually help in reducing the time. So what we can do is okay. First of all, let me just set up the ID. Sum of powers and nums and k, right? Nums and k. We have 1, 2, 3, 4, and k is also 4. Okay. So first thing that I can think of is let's just sort them, because then it will help in finding the minimum difference that is in the array. So what I will do is first of all nums sort nums dot begin and nums dot end. Okay. So once this array is sorted, I will have choices. Like now it is very easy. I mean, I can either take an element or not take, right? So let's just try to write the recursion. So let's say auto db. Now I will have, like, if I'm at index I, so let's say if I'm at an index, so I will have two choices, like take the ith element and put it in the subsequence, or not take, right? So I will only have these two choices. So what will be the states? Like if I take the ith element, what will the DP become? So let's say int answer equals to 0, and if I want to, if I don't want to take this, so let's say, okay, sorry, let's say I want to take this element. So what things will change? If I'm at an index, then answer will become plus equals to DP of index plus 1. So I'm going to the next index, and what things will change? The minimum difference may change, right? So if I had like if I had a subsequence, okay, that was ending somewhere. Let's say this is the previous index that where the index was ending, and now I am at some I index, and I decided to take this. So if the minimum difference of this array was min, and now I add I, so the new subsequence will become this whole thing plus a new element that was at index I, and the min d will become minimum of min d comma the difference of these two values. So nums I minus nums previous, right? So this is what will happen. So I want to have a previous index also. So int previous, and one more thing, I this length, the length of this DP, sorry, the length of the subsequence cannot be should be exactly k, right? So let's say int left. So how many elements are left that I need to take, like that. So if I take it, if I or let's say first is not take. So if I don't want to take it, so I will go to index plus 1. The previous will remain same and the left will remain same, right? And I will need one more thing, the min difference, right? So these are like the four DP states. So min difference will become what? Min difference will become minimum of what? Okay, this is tough because the previous, like if I'm at the first element, the previous cannot be will be nothing. So how do I handle it? That is also a tough question. I think I'm going to use something called coordinate compression in this. So I'm going to use like coordinate. I mean, it is not really. I won't exactly call it coordinate compression because I also want to memoize this, right? So memoization is also tough. So I think that is why this is a Leetcode hard problem. Yeah. Okay. Okay. Let's say first of all, let's write the base cases. Like if the index, let's say int n equals to nums dot size. So if I'm at index, if the index equals n, and the left uh, and left is greater than 0, then this will not contribute anything. Otherwise, if the left is equals that k value, then I will return min, so the minimum difference that I had. Otherwise, okay, I also want to use this mod value, right? So let's also have it here. Okay, now otherwise I have two choices. Let's say answer equals to 0. Um, okay, answer equals to 0. Now, first, the cases when I don't want to take the element, right? So answer plus equals to dp of index plus 1, everything remains same, previous, left, and min, right? So this is good. Or let's try to write this answer plus this, and let's take the mod value. Why this giving error? Because I have set the type to auto. Int, and int. So now that should work. Yeah. And so this is when I don't want to take the element. Okay. And in the end, I should return the answer. Return answer. And if I want to take this element, I have to make some choices. Like if if the previous, what if the previous was -1? Because I want to simply return one thing. dp of start from index 0, previous is -1, there is no previous element, and left is k. So I want to have at least k more elements in this subsequence, and min difference is very large value, let's say 10 to the power 9. Okay, now, so I have choices like if the previous equals -1, then I will return, not return. Let's say if I take this element, so it will become dp of index plus 1, previous will become this index, left will become left -1 obviously, and min difference will become wait a second, min difference will become what? I think I will just put the mod value here. Doesn't really matter. I think I can even uh, do it like this. Okay, yeah, I think this should work. Else answer plus equals to dp of index plus 1, previous will become I, and left -1 obviously, and minimum of min difference comma what? Min difference comma that value, um, nums I minus nums previous. So this is like an abstract dp, take or not take. Okay, why this is happening? I was not declared. Okay, so it should be index. Sorry about that. Yeah, so I think this should work, but the problem is that it is not memoized. Where is this index? Okay, so we are getting a lot of zeros. Okay, now why is this happening? Okay, we have let's make it like this. Mm, I think it is because I did not take mod. So answer plus and take mod at the end. And similarly, let's make this answer plus mod. Yeah. What? Sorry about that. I think this is because if left equals 0 and not left equals to k, that is because this is happening here. Now we're getting 1, which is wrong. What should be the answer for this one? The answer should be 4 and k equals to 3. Okay, I wrote the wrong k. Yeah. Okay, so it took 2 seconds to run, but our answer is correct. Now we just need to memorize this db. And how do we memorize this? First of all, this index value. Like let's analyze each of the states. So now we are on memoization part. So when we want to memorize such a dp, so we have the states. One is the index, right? So this is easy. Index is only from 0 to n. So this is good. Like this will take big O of n space. So that is okay. Next we have is previous. Previous can also range from 0 to n. So this will take big O of n space. So that is also okay. Next we have the left pointer. So this will take left will take big O of k space, right? So this is like big O of k. And then what do we have? The min difference. Now this is tough. The min difference can range from anything from -10 to the power 8, 9 to 10 to the power 9. So this is what we want to avoid, right? So I have two choices, like I can use an unordered map, or maybe I can use coordinate compression. So I have two choices. I can use a map to memorize this, or I can use a what should I say, something like coordinate compression, COORDINATE, coordinate compression. So if I was using Python, I would have used a map, but right now I want to use coordinate compression. So basically, this is nothing very advanced. So you can follow along if you are watching it till here. Now, uh, we just want to memorize it, right? So since I have sorted it, the nums will be the differences. Let's get all the differences first. So let's have a vector int. How do we coordinate compress something? First, we want to get a vector int of differences. Okay. Right. Let's have or let's make it a set first, because I want to get only the distinct that. So set int s, and for in range n, let's go from 1 to n. S dot insert nums I minus nums I minus 1. So this will get all the differences that are possible and insert it into a set. And now I want to make a vector of differences, and for in s, difference dot pushback, what I. So now I have all the differences in the sorted order, and they are added in this differences, because there can only be n square, big of n square maximum differences, right? So these the number of differences simply big of n square, which is very small. So I can add them to a vector, and now once these are added in this vector, I want to find the index that at which this difference is present. So since I want to coordinate compress it, uh, how can we do it? Okay, let's have a map of intent. Let's call it MP, and let's have an pointer of 0. So for int I, in difference, I can say MP of I, for int x in difference, MP of x equals to I plus plus. So this will assign every difference an index. Like if my differences were something like 1, 2, 5, 7, 11, this will assign a value of 0, 1, 2, 3, 4. So this 0 will be mapped to, this one difference will map to 0, this will map to 1, like that. So I'm assigning these index values, okay, like that. Let's, should I use I? Yeah, I can use I. So this I will contain the value, and now I can make a memo of vector 4 times vector int, like this. So this is my memo, um, basically the memoization part. And now index is like n plus 1 in length, the previous is also n plus 1 in length, and then we have k plus 1 in length, and then we have what, I plus 1 in length, and initially let's say it is minus 1. Okay. So I hope, should I know this is a bit tedious, but yeah, it is not something very complicated, so don't try to complicate it. But yeah, let's first get the index in this. So let's say ind equals to what? So if my um, previous, okay, how should I do it? At max, the min difference can go to how much? I mean, there is a default value for it, right? Since I'm starting it from here, I should also do this s dot insert mod, right? Yeah. So let's get the index first. So let's say int the index of this min difference will be equals to mp of mindy. Okay. And once I have this, what can I do? Once I have this, I will say like if memo of index previous left and mindy, not mindy, ind not equals to -1. So if this value is not equals to -1, then I will simply return this whole thing. So return this whole thing. Otherwise, I will set this value to the value that I am returning. So this completes the memoization also. Okay, we are getting some segmentation fault. Okay, let's try to debug it maybe. Okay, so the index that was created was 1, and why is that? Because previous was -1 and then mod is this. Let me debug the difference array also. So in this the differences are 1, like seriously they are 1. So index is 1 for this. Yeah, let's make this I plus 2. Okay, I think I get it now because previous was -1 here. Yeah, so that is causing a problem. Let's make this previous +1 instead. Maybe that will help. Yeah, so now we are getting the correct answers. And just to avoid any errors, I will make this part, the k+1 part, as k+2. So I think this one is now working. Yeah. So we are getting the correct answers. Let's just do one more thing. I will test it for two other test cases also. So you have two, or let's just copy everything and paste it here. Let's first run this and see if it is working. We got accepted. Let's try to submit this. Okay, we are getting some wrong answers. The output is 6 and the expected value is 9. Okay. Um, what is the value of k? K is 3, which is okay. Hmm. So why are we getting something different here? The problem is, by the way, how many test cases passed? The 200 test cases failed. Why is this? What if I don't memorize it? Will it give me the same the correct answer then? Okay, so without memorization, it is giving me correct answer. That means I'm not memorizing it correctly. So index previous +1. I just need to handle how to memorize it correctly. So for that, what can we do? This sucks. Like this is the correct function, DP function, but I just don't know how to memorize it. Okay. S dot insert mod. I think that should be okay. Let's just debug the differences. So 1, 3, 21 and this. So when we sort it, minus 16 will come first. Then okay, minus 12, yeah, 1 is good. Wait a second. Am I taking the absolute differences? Um, I think the mistake that I'm making is difference dot pushback mod. Yeah, I should push mod directly in here. And why is that? Because no, that won't help. Okay. K is good. I plus 2. This is also okay. Now, sorry guys, I really don't know how to memorize it correctly. I think I will just ask ChatGPT to memorize this one and see if it works. I mean, the code is correct. I just need to memorize it somehow. So should I ask ChatGPT to do this for me? No, just give me some time. Yeah. Uh, I have 20 minutes left, so yeah. How do I go about memorizing this code? So we have a memo, and we want to memorize this. Okay, since we have consecutive elements, and s dot insert mod, so mod will be in there. Num minus num minus 1, that is good. Okay, so vector int n plus 1 and vector int k plus 2, vector int I plus 2 and minus 1. MP of this min difference that we have is here. If memo of index previous plus 1 left and mending. Hmm. Okay, now we are also getting some segmentation faults. Why is that? if left equal to then this is correct. I get the index end index previous plus one left and end, and that is okay. Memo index previous plus one left and index is equals to answer. I'm not sure why this is not working. I mean it should. The way. Okay, so we have index previous left and mid plus one, mid difference plus one. If previous equals minus one, answer is equals to index plus one, comma mod. Why do we have a mod? 1e9, a very large value, and then we take a modulus again. No, the recursion is correct, and memoization is the problem. Okay, I think I will just ask ChatGPT to memoize it now. I'm not really sure how to go about it. Or maybe if I can, should I try to do it like unordered map? Maybe. Yeah, this last vector int, what I can do is I can remove it from here and make it an unordered map, or simply a map of int instead, because I don't know the min difference values, right? So I can make it like this, and in the end, like instead of having this value, I can say a map of int like this, or can I say it like this? Okay, let's try to initialize everything again. So what we have is a n plus 1 length memo, and we want to have vector of vector of vector of like that, and then in the end we want to have a map of intent. So memo of n plus 1, and index is done. Then we want to have vector. Let's say we want to have a vector which will handle the previous, then we want to have a vector which will handle a left, and then we want to have map of intent, right? And this will go for k plus 2 length, and then we want to have a vector of map of intent, right? And this will go for the length of how much no, I think I am overkilling it a bit. Okay, this is tough. I mean, it is not so tough, it is simple, but okay. First we want to have index which is of length n, right? So let's say vector of let's try to do that first. Vector int of and this is called memo, and it is first it is in length this, and then it is in length like this. Okay, and now in place of this vector int I want to have a left, so left is also a vector int, right? So I want to have another vector int in this place, and vector int of left is k plus 2 length and 0, like that. Yeah, and now in place of this int I want to have a map intent. Yeah, so I will replace this int by map intent. Right. So I don't really need this min difference index anymore. So I will not have to use any kind of this stuff. So these things won't matter now. And now I can simply like let's say if memo of index previous plus one left and min, then if it has some value, then I will simply return it. Okay. Otherwise, I will simply set some value here before returning. Return this equals to answer. Will this work now? Yeah, now it is working, and I think we solved it now. Let's try to submit this and see if it works. Or should I make this unordered map? I mean, there are very uh, let's let's just make this unordered map to avoid any kind of TLE issues. Yeah. Okay, so memoization was the problem, and I think we solved it. Let's first try to run this on the test cases. Yeah, let's submit it. Okay, we got a TLE, and 4 test cases are still failing, but okay, it's already 12:48, so I think, sorry guys, I was not able to solve it, but yeah, I mean, it is almost solved, but if you can point out the mistake that I have made here, then it will be really helpful. I mean, it is giving a TLE. It is some kind of memoization issue. I have to memorize it properly. I'm not really sure. Maybe what I can do is I can try to hash these values. If because n is only 50. Okay, let's I just got a random idea. N is still 50, and like this is 50, right? So this is 50. Previous is also like -1, so I can add it to +1. So previous is also from 0 to 50 only. Everything is like 50, 50, 50. So what I can do is let's say a prime number 51. So I can say n into p plus previous into p square plus what is that? What do we have? Left is also from 0 to something like that. So yeah, I mean the differences are also still big of n square only, right? So n square means 50 into 50, which is equals to 2500. So if I have 2500 to the power how much? 1, 2, 3, 4. Is this in an integer? Yeah, I think I got a nice idea. What I can do is instead of making something so big like this, uh, unordered map uh, of int, let's make it a long int comma int, and let's call this memo. Yeah. So what we can do is I can try to hash this value. Um, let's say my prime number will be equals to n into n. Okay, so I will have something like index times p plus let's make it previous plus 1 times p plus 1 okay, plus not p plus 1, let's make it p times p plus that value. What is it here? We used index, we used previous. Then I want to have left times p times p times p, and plus the min difference value times p times p times p times p. So this hash value will be calculated in big of 1, and since n is only 50 into 50, which is 2500, 2500 to the power of 4, this is how much? Okay, it is quite a large number. So I mean, how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so it is still 10 to the power 14, so I can make it long end, and this will fit in the hash value. Okay, and let's also have a value of visited. So visited, okay. Um, so if visited of hash equals 1, then I will return memo of hash, and otherwise I will say memo of hash equals to answer, and before doing this I will say visited of hash equals 1. So let's see if this works or not. Okay, so int doesn't work, like maybe it is because I have it here. Okay, so now this is working, and let's try to run this and see if it works. Okay, runtime error, overflow. What is this? Cannot be presented in type int. I think why don't I just make everything long instead, so that it will work. Okay, let's do it like this. Actually, what I will do is I will make this p value very large. Like, yeah, I think this should work. I don't have much time now, so if this doesn't work, then I think I will just stop now. Yeah. Okay, what do we have? Runtime error, signed integer overflow, can't be stored as type long. Okay, so we want to have even bigger integers. Uh, I mean, the differences are always positive, so it can happen that I have very large differences in the range of 10 to the power 9. Yeah, these differences are the issue. So how can I actually memorize this such kind of differences? But it is also true that the differences are very few in value. Okay, so the problem is I can't really multiply these two values because they are too large. So why don't I multiply the big values? Like, why don't I make it in reverse order? So let's say P times P times P times P, and let's have 3 times here and 2 times here. Actually, why don't I start from 0? Let's have 0 here. Sorry about that. 0, 1, 2, and 3. Yeah, I don't need to go to very large powers, and I think this will work now. Yeah, this is right now it is giving correct answer, but I will have to see if this works. And we are getting a wrong answer, I think, because it should be in the reverse order. Yeah, I was just thinking about that right now. So index, let's say from 0, then 1, then 2, and let's have 3 till here. P times P times P. And let's actually make it unsigned. At least we didn't get a TLE, and okay, only 2 test cases were not passing in this case. And now we are getting TLE. Oh, only this test case is not passing. Uh, I don't know how to go about this now. I mean, I've tried almost everything. The bucket size is quite small, right? Let's say, let's just say memo dot, I think I get it now. Let's say memo dot reserve and visitor dot reserve, and I think this should work now. Okay, we are still getting DLE. Okay, so I mean, this is the only test case that is not passing, and I'm not really sure what to do now. Okay, guys, I think I have to go. Sorry about that. Let's see. I think, but the recursion is correct. I don't know what to say about this, but yeah, I think I will just stop right now. And if you have any other doubts, you can comment down. If you want more of such videos, then kindly tell me in the comments. I will see you guys next time. Thank you.